go ahead and write the title, Nail Lab. What we're going to be doing in this activity is we're going to use iron nails, and those are solid, and we're going to submerge them in a solution of copper 2 chloride. This is the same blue liquid that we used in our YouTube electrolysis lab. Remember, aqueous means that the copper and the chloride ions are in solution. So I've drawn the particles loose because, of course, they will separate. They are attracted to the water. Some things we already know is that the subscript S stands for solid, AQ is aqueous, and that's referring to in water. Reactants is the term that we use to refer to the things that we put into a chemical equation. The chemical reactants are on the left side of the arrow in a chemical equation. In this case, iron and copper 2 chloride. The products are on the right side of the arrow in a chemical equation, and those are the things that will form. And finally, the arrow itself in a chemical equation means yields or reacts to form. So I would like for us to start by making a couple of hypotheses. And the first question I have is, which elements will exist on the product side of the reaction? So here are our reactants, but after the reaction has occurred, what things do you think will still exist? Let's do a little brainstorming together. Is it likely that we will have the iron and the copper and the chlorine together? Well, remember, we said two metals do not typically form a compound, so it's not likely that iron and copper will be attracted to each other. So any combination of iron and copper is not the best choice. What other possible combinations are likely? How about iron with the chlorine and copper? That's a choice. That would be a reasonable hypothesis based on what we have learned. The second question I'd like for you to consider is, will more, less, or the same amount of matter exist after the reaction as before the reaction? Well, let's consider. So we started with a certain number of particles on the left side. Will we have more particles than that, fewer, or the same amount on the right side? Have we learned anything about the conservation of matter and mass? I will leave the second hypothesis for you to complete on your own. We're going to collect data, so please add a data table to your notes. The mass of the iron nail before the reaction, the mass of the iron nail after the reaction, and the mass of the copper that is produced.
Color, and again, I'm looking for a target of about 6 to 8.5 grams. So I'm actually going to take one of these bigger chunks, start with that, and that's about 1. And I'm over 6 grams, so I'm going to go ahead and use that value, 6.313 grams. That is my copper chloride. To dissolve the copper 2 chloride. It suggests about 60 milliliters, and on this particular beaker it is marked. I don't need to be exact, but around 60 milliliters will be a good amount. So I'm trying to dissolve the copper 2 chloride. And you get a nice bright blue solution. Then to make the reaction go, it says place the 2D side up and swirl a little bit. And you can already see that some copper has formed, and that will copper that has formed on the surface of the nails. Today's procedure is all about collecting that copper off down into the beaker. You'll also notice that the surface of the nails looks different, and it actually is thinner because, again, while the copper forms, you also have metallic iron to ionic plus 2 iron ions, and they get dissolved in the solution. So I'm going to try to rinse any of that copper down into the beaker that may have been clinging to the nails. You're just going to place them in another beaker. If you have a 150 milliliter beaker, that's a good fit. I'll place those there. So next up, those are going to be dried. I would like to know the mass of iron that's left. So those are going to go to the drying oven, and I'll show you what that looks like in a minute. Doing the investigation, and it'll be warm inside. There will probably be other beakers inside already drying, and you can just place your iron nails inside of that drying oven. Our goal for the next part of the investigation is to collect and clean the copper. We're going to use a lab technique called decanting. So the procedure says that we're going to decant the liquid, which means to pour off the liquid on the top, and rinse the copper a few times to try to clean it and rinse off any dissolved iron chloride that might be clinging to the copper. So to decant, you're going to want to pick a beaker, just a waste beaker, to collect the liquid that you're pouring off. And it helps to hold a stirring rod across the beaker. And that just helps as you pour, maybe stopping any solid particles that might be otherwise pouring out of the spout of the beaker. So you want to kind of hold it like that. And you want to pour slowly. And the stirring rod can also just help direct some of that liquid. Now I'm going to lose some copper at this step. I'm going to try not to, but chances are you may see some fine particles of copper pour out of the beaker. And the idea is I want to pour a good amount off in that first step, but I don't want to pour it so rapidly that I lose a bunch of the copper that formed. So I have a good deal of copper in here, and I want to clean it over the next couple of steps. Then we can take a look at our iron nails and see how much mass is left on those. Get up a little bit closer. There we go. Is that the nails have clearly been kind of eroded and eaten away. There's a little bit of rusty looking, maybe iron oxide or maybe even some copper that's clinging there. But we want to get a measurement of the mass of those nails and see how that matches our stoichiometric calculations. So that would be a next step. Yesterday, the mass of the nails to start was 14.294 grams. It has decreased because some of that has been converted into the iron chloride product. So we can check that value, the 12.269 grams, against our BCA chart and stoichiometric calculations and see how close we are to the prediction.
Now that we've gotten a chance to see the reaction take place, we do know that these are the products. So I'll go ahead and bolden them. And I'll also fill in an S because the copper that was produced was the solid that was in the beaker at the end of the reaction, and we were able to mass it. The iron chloride is a salt, metal, nonmetal, an ionic compound. So in water, it was the part of the liquid that was in the beaker, the green, murky liquid that we poured out as waste liquid, because we're not measuring that. So this does look like a reasonable chemical reaction. Let's also fill in our data into the data.
And I'll put the entire beaker on the balance. And I'm seeing a value of 56.876. Then I will know how much copper was actually produced. And it looks like 53.871 grams. So it was up above 56 grams before. You can see that the water can add quite a bit of mass. Very important.